We want to solve the equation sin theta plus 30 degrees is equal to cos theta plus 45 degrees for values of theta between 0 degrees and 360 degrees. So let's start with the equation. We have the sine of theta plus 30 degrees is equal to the cosine of theta plus 45 degrees. We can use the compound angle formulae to expand these. This will be sin theta cos 30 plus cos theta sin 30. And on this side we'll have cos theta cos 45 degrees minus sin theta sin 45 degrees. We want to get all the sin thetas on one side and the cos thetas on the other. If we add sin theta sin 45 to both sides, we get sin theta cos 30 plus sin theta sin 45, and at the same time if we subtract the cos theta sin 30 from both sides, we get cos theta cos 45, which is already on the right, take away the cos theta sin 30. So on the left hand side we now have a common factor of sin theta. If we now open a bracket, we have cos 30 plus sin 45, and on the right hand side we have a common factor of cos theta, open a bracket, and we have cos 45, take away sin 30. So let's divide both sides by cos theta. Sin theta over cos theta is tan theta, and at the same time divide both sides by this bracket. So on the right hand side we get cos 45 degrees minus sin 30 degrees divided by cos 30 degrees plus sin 45 degrees. Are all exact values that we should know. However, there's no real advantage to using them, so let's just use the calculator. Let's store all of this value. Theta is then going to be the inverse tangent of this value, and evaluating that gives us 7.5 degrees exactly. To find the other solution between 0 and 360, we'll use a cast diagram. So we have ASTC. The first solution is here in the A quadrant, and we have a tangent which is a positive number, so the other one will be in the T quadrant. By symmetry, 7.5 degrees beyond 180. So our solutions are 7.5 degrees and 187.5 degrees.